Hi everyone, today we're covering uronic acid pathway. Now, there's an alternative pathway of glucose metabolism that produces UDP glucuronic acid, and it is important. Why do we need UDP glucuronic acid? This one, it is important for GAG production, it's important for detoxification, and it's important for conjugation reactions. So it's important for GAGs, which is glycose aminoglycans, and also for detoxification and conjugation reactions. Now, what exactly happens is, let's talk about the first step. You have glucose and you have to convert that to glucose 6 phosphate. So that's the first step. So for that, obviously, you need hexokinase or glucokinase. This is such a babyish step, a very easy step. Then glucose 6 phosphate has to be converted to glucose 1 phosphate. For that, we need phosphoglucomutase. Very easy reaction as well because this is repeated so many times. Phosphoglucomutase. After that, you need glucose 1 phosphate. It needs to be converted to UDP glucose. Here you need pyrophosphorylase, UDP glucose pyrophosphorylase. What happens here is, if you can recall, these are the steps that we have already studied. These steps we've already studied until here. Now here what happens is that you're basically trying to incorporate UTP. So when you add in here UTP, if you can recall, this was happening in glycogen synthesis as well. So if you add in UTP, you will have glucose with the UDP. So UDP glucose, and you needed pyrophosphorylase there. And then this was being released, and this broke down into two inorganic phosphate, and the energy from this reaction was used to drive the entire reaction. Now, after UDP glucose, so pyrophosphorylase. I hope that's clear. So first of all hexokinase, then phosphoglucomutase, then pyrophosphorylase, and then you have UDP glucose. It gets converted to UDP glucuronate, UDP glucuronic acid or glucuronate, and for this you need UDP glucose dehydrogenase. And this is a very important step because it's a rate limiting step. So UDP glucose gets converted to UDP glucuronic acid. For this you need UDP glucose dehydrogenase. You need 2 NAD and it produces NADH. Now you got glucuronic acid, so that's it. This is the uronic acid pathway. So again, first of all, glucose, hexokinase, glucose 6 phosphate, and then glucose 6 phosphate gets converted to glucose 1 phosphate by phosphoglucomutase, and then your glucose 1 phosphate, you have to incorporate UDP in that. In order to incorporate UDP, you will need pyrophosphorylase. So UDP glucose pyrophosphorylase, and after that, you'll get UDP glucose. Now, this UDP glucose dehydrogenase will convert it to UDP glucuronate. UDP glucuronate. And for this also you need 2 NAD. And this gets converted to, and now what is the significance of your UDP glucuronic acid? This is important. Its fate will be that it will conjugate with bilirubin, with the steroid hormones, and with the drugs and toxins. With bilirubin, steroid hormones, and drugs and toxins, and other than that, so it's important with the conjugation. So it helps with conjugation and formation of GAGs, which is glycose aminoglycans, and can also form L-xylulose, right? Xylulose. Now, okay, what's the regulation? It depends on availability of the UDP glucose, and this is the rate limiting step. So it depends on the concentration of UDP glucose. Otherwise, there's no major hormonal regulation, and activity increases when detoxification demand is high. So whenever detoxification demand is high, that's when this increases. So in short, what is glucuronate important for? For conjugation and for detoxification. So for conjugation, with bilirubin and all the other things like steroid hormones, drugs and toxin, detoxification, and also glycose aminoglycans production. Now, biomedical importance, exactly same things that I mentioned, detoxification and formation of GAGs, and then other than that, also conjugation with the three things that I've already mentioned above. And clinical correlation, it can, if there is defective bilirubin conjugation, there'll be Crigler-Najjar syndrome and Gilbert syndrome. That's another clinical relation that you can study in regards to it. Let's just look at this: phosphoglucomutase, then pyrophosphorylase, then you have dehydrogenase, and finally you got this. Now, with the help of this, you can do whatever you want. And yeah, that's it.